Okay. Can someone confirm is my screen visible or not?
Yes, sir.
Okay. So, in the last session, I hope you guys have seen relational algebra, I mean the relational algebra expressions and tuple relational calculus, domain relational calculus, right? So, in this session, we'll look for how to design a schema and what are the various things that has been involved in the schema, what are the various types of relationships. All these things we will cover in this session. So these were again it's same relational algebra is there, double relational and domain relational. So now let's come from this one entity sets. So what does mean by entity sets? Entity, there is a difference between entity and entity set. Entity is an object that exists distinguishable from other objects. You can look at this definition whenever you want. So, in fact, in simple words, if I wanted to say entity sets, you can think as a table in a database where you can see all those attributes. It's nothing but the set of entities that share same type because each row you can consider as an entity and all the set of entities will of course will share a same type of data. Of course the data might present and vary but all will be in same data type. That's what it's implying. So entity set you can just think of as a table. That is what is present here. And coming forward there are various types of entity set. Okay, there is some called strong entity set and weak entity set.
Excuse me, sir.
Strong entities,
No, sir,
yeah,
it is said I didn't get it. What do you mean by this? It exists and
where
what is entity?
entity is an object.
Object.
So, for example, in a student table, student is an entity, and the attributes like student ID, course ID, and set of all attributes are entity sets. Like each row is an entity.
Mm.
In DBMS, what is entity, sir? In our
Entity you can, yeah, entity you can define as a row. So let's say the student table is there, and in student table you can see roll number, name, subject, grade, all these things, right? And each row will have a one student. So each row can consider as an entity as a whole. You can consider this as a entity sets.
okay, sir. So row is an entity and entity set complete table is a set.
Yeah. So maybe in upcoming slides it will be clear when I start saying. So in strong entity set, it's nothing but contains sufficient attributes to uniquely identify all its entities. Again, you can repeatedly see this entity word is keep on coming. So here, what it does, you can simply remember a strong entity set should have a primary key to uniquely identify each of the rows. That is mean by strong entity set. So if you consider as a table, it should have some primary key, right, to uniquely identify all the rows.
Yes, sir.
So that is, if there is some primary key to uniquely identify, that is considered as strong entity set. And in weak entity set, there could be some table which you may not have a primary key. That is something called a weak entity set. Its definition itself says does not contain sufficient attributes because primary can be one or together also. You can see studied various types of key which will be detailed in weak 5. Okay. So it does not contain sufficient attribute, one or more attributes to uniquely identify its entities. That is called weak entity set. So what does it imply is a primary key does not exist. in weak entity set. Okay. But there could be something called partial key, which is we will be calling as discriminator, and which we also designing we could see that is underlined dashed line, something like this. So that is called something as discriminator. So what is the use of having weak entity set? And if we are having weak entity set, how can we uniquely identify what is given in each row? Because sometimes you might think, what's the purpose of having those rows if I'm not able to uniquely identify, right?
Yes.
Yes, sir.
So while designing a database, so there could be some aspects in where you have to store some information safely in another table, but you may not have a primary key. In that case, you might have studied in week 2, we can have a surrogate key, synthetic key, something. That is one of the option. If you don't like to have surrogate key or synthetic key, something that is called a partial key, which is nothing but which itself cannot identify. So partial key, nothing but if you take a partial key, using partial key also you cannot identify each row uniquely. But if you combine this partial key with some other primary key of other table, then you will be able to identify all the rows present in weak entity set uniquely. So primary key of other table. Because weak entity set cannot exist independently. Something I haven't mentioned, right? Cannot exist independently. Because there is no use if you are having weak entity set independently, there is no use of having a table, right? It should be linked with some other table, then only it will be helpful for you.
So surrogate key or synthetic key, these are partial key only.
Hmm.
We can call them partial key.
Sorry.
Surrogate key or what synthetic key, can we call those partial key?
No, no. You cannot call synthetic key or surrogate key as partial. Partial key is nothing but it's one of the attribute present in the weak entity set. But using that, you may not be able to, sorry, you may not, so you cannot identify the entities uniquely. Okay, I mean the rows uniquely. So, but if you combine that key with some other primary key of other table, then you will be able to identify those rows uniquely. That is why we are calling this as discriminant.
So can you give examples? Because
Uh,
it is not being clear.
okay. Okay, let's look at upcoming slide, then it will be much clearer. Okay. So as I said, weak entity sets cannot exist independently. As of now, just remember this. I'll show you demonstration along with the schema diagrams so that you'll be able to understand it. And it features in the model relationship with a strong entity set. As I said, it cannot exist independently, so it has to combine with some strong entity set. This kind of relationship is called identifying relationship. So weak entity set must link with strong entity set. So this kind of relationship, what we are calling as identifying relationship. And the primary key of weak entity set, as I said, it is discriminated and primary key of strong entity set, which is nothing but another table. And this what we said as partial key discriminator. Okay. And it must have total participation, identifying relationship. Let's again come to a point what is mean by total participation later in upcoming slides. So far, these are the things which you need to remember. Simply, as of now, what you can remember is weak entities set is nothing but a table which doesn't have a primary key, so that it cannot identify all those rows uniquely. So to identify the rows uniquely, what we need to do is we need to combine a primary key with other table, which is nothing but strong entity set. And if you are doing that, that's what we call as identifying relationship. And we also see it cannot exist independently. So far, I'll come to a point what is mean by discriminator, how it combines with other entity sets also. Any doubts?
So
No,
what
sir.
is participation?
Okay. Okay. Then what
Sir,
is
what is
attributes?
total participation?
Sorry.
Can you describe total participation once again?
Yeah, we'll come to total participation, partial participation later. It's all theoretically. I put it before. Well, before coming to the concept, we'll see what is mean by that.
Okay, sir.
Okay. Attributes. Now coming to attributes, attribute is a property associated entity set. It's nothing but columns. You can say in simple words. Uh, Simple words you can say as column, but there are several attributes you should say as attributes. Okay. Simple attribute, composite attribute, single valued attribute, multi-valued attribute, derived attribute. So simple attribute is nothing but as usual whatever we store. Generally, that is what. Composite attributes is nothing but we are splitting one attribute into multiple pieces like first name, middle name, last name. So this is composite attribute. Single valued attribute, again, it can contain only one value. Multi-valued attributes, nothing but phone numbers. Like for example, one person may have so many phone numbers. One person may have so many email IDs. You can consider email IDs also. These are something called multi-valued attributes. So where in real world, one person can have many things so that you have to store it in table, right? So these are called multi-valued attributes. And derived attributes is nothing but age. So age we can derive from the date of birth. So we don't need to store age explicitly in the table. That is one of the options. If you want to store, you can store it as a trigger, as we have seen in week 3. So it's up to you because maybe in later weeks, if you see there are some performance issue that also you need to consider while designing the schema. That's right. Okay.
Sir,
So
what is composite attribute is like address kind of thing.
you can say address also. Address is also a good example.
And
Address,
single
if you
value,
say street, that is one. City, that is one. District, pin code. This is also one of the composite attributes.
and
Because
single
address you
value.
can split it into multiple parts. Right?
Sir, I joined a little bit late. Could you just give a small recap of entity set?
Okay. Entity set, you can, it's nothing but a set of entities. And you can think as a table. Entity set is nothing but a table. And entity means you can say each row as entity. Okay.
What you told about simple attributes?
I haven't told anything. Is it simple attributes mean nothing? If you, as usual, normally what we are doing, roll number, subject, all these things comes under simple attribute
How
and
it is
single
different
value
from
attribute.
single valued attribute?
A single valued attribute, it's nothing but it can contain only single value, not like phone numbers or email IDs.
No, simple and single valued. How
Both,
differentiate?
both you can say there is no much differentiation between simple attribute and single valued attribute.
Okay.
So any doubt here before moving on?
No, sir. So when more examples will be there, the things will be more clear. Yeah.
So if you look at here, the same thing, this is called as composite attribute. This is multi-valued attribute. This is derived attribute. And this is again composite attribute. And you can see the address itself a composite attribute contains street, city, state, zip. And within street again you have another composite attribute. Okay. These are the way of representing the attributes in a tabular form. If in exam they have given any entity sets like this is itself one of the entity set. It's nothing but it defines the instructor table. These were the columns present, and these were the attributes that were there. Right? This is entity set, nothing. So this is how we used to uh, pictorially present the various types of attributes in the entity set. And the underline says this is a primary.
Primary.
Any doubts here?
No, sir.
Okay. And now come to the important part, which is really important not only for exams. If you wanted to design some schema, and this is very much important, the ER diagrams. The ER diagram is nothing but a entity relationship diagram. Entity you consider as table, and you in between you will be defining some relationship what is there. Because so far I think we have not seen any relationships in week 2 and week 3. All we have seen is SQL, primary key, foreign key, and using foreign key we used to join left outer join, primary join, sorry, cross join, natural join, all those joins, right?
Yes.
And so far we have seen that. Now we are coming to the ER diagram. What is the purposes? What is the relationship that exists between two tables apart from having primary key, foreign keys? So that's where the ER diagram comes. And using this, uh, you can design an entire schema of the database. Like in pgadmin, you have seen the schema, right? There used to be some tables where the primary key pointing to the foreign key of other table, if you guys have seen. So that kind of schema you will be able to design by using this concept. And before looking at the ER diagram, some things which you guys wanted to fix or remember that you cannot say something this is not important or something. These are some set of rules for designing the ER diagrams. Rectangles is nothing but represent entities. Attributes are listed inside the rectangle. Underline indicates a primary key. Diamond, this diamond symbol, something like this. This represents relationship set. And total participation indicates double line like this. And weak entity set represented by a double rectangle. We have seen previously what is mean by weak entity set. This will be represented like this using double rectangle. In normal rectangle, this is, and inside this attributes will be there. If it is underlined, it's a primary key. Okay. Okay. Now come to a topic where the various types of relationship exist. So in schema, you might have seen, for example, if you take a FLIS data set, there exists a team, right? Team table, and player table is also there, right? And you might have seen here team ID as a primary key. And here you might have seen team ID is a foreign key, and here player ID is a primary key. Have you guys noticed this or not? This is a foreign key in FLIS dataset
Yeah.
while solving the SQL questions. So,
Yes, sir. Yes, sir.
so this is something, it has relationship with this table, right? So how do we define this relationship? What is the meaning of this relationship, and how should we say define, like, the team can have many players or player can have many teams? In this case, if you have seen carefully, in the FLIS data set, team can have many players, right? That is what it is implying, because only there are 6 teams and there are almost around 100 players. So each team is around 10 or 11 players. You might have seen in the FLIS data set. So all this, where it comes is like, how do you define this? A team can have multiple players. How do you define these constraints while designing the database? It's not just simple about you have a primary key, foreign key, or linking the table. It's not mm, not easy to design a database. You have to have some set of constraints and logics, because that's where the industry also, right? Because in some industries, they might have give specific cases. If you go and design a database, let's take a classic example of employee database itself. The all employees must have unique their bank account details. It doesn't mean this employee can have multiple bank account details, because all their salary will be credited to only one of their bank account. It says uh, all employees should have only one bank account details. Let's say bank account details. So what does it denotes? How do you enforce this constraint? That you can maybe later have a look at the code, but you should enforce this constraint. So far, this designing comes, and you can say every employee has only one bank account detail, and every bank account detail has only one employee. This is what we call as one-to-one relationship.
Yes, sir.
And this is how we pictorially represent also. And here, the instructor ID, this is primary key, as we are saying, this is underlined. And student, we have also underlined, this is a primary key. Okay. And this arrow, like, carefully notice the arrows. Okay, whenever you see something, see the pictorial one. This arrows, like the arrow mark indicates left one, right? This says this is 1, and here also this arrow indicates this is 1. This is nothing but one-to-one relationship between instructor and student. So you can see the wordings here. Each instructor has at most one student, and each student has at most one instructor. Why we are saying at most one, not exactly equal to one student or something? Because that again depends on the constraint, that what you are gonna have using foreign key. Because if foreign key is not null, that is exactly equal to 1. If foreign key is, if it can be null, it is at most 1, right?
Sir, can you repeat it? One-to-one relationship. So, can you use our tables, our database, FLIS or LIS or university database?
Okay. In FILIS, there is some team table and manager table. Every team has only one manager. If you have seen the database, the team IDs, then you can see T01, 2 up to 6, and also similarly manager 1 up to manager 6. And this is nothing but a one-to-one relationship. And you can pictorially represent anything here. uh, this one relationship set name something advisor or something, whatever,
Advisor
because
is
it's
some
not
of relation.
it's just a relationship name. It's not a real table in your database.
Okay. And this arrow represents the one-to-one relationship.
Yeah, these arrows you need to carefully note it down. If the arrow symbols change, the relationship changes.
Okay, sir. Right, sir. Okay.
And one-to-many relationship. As you seen, there is again a same table. What I have changed is uh, the arrow. Lastly, we have seen arrow like this. Now I don't have this arrow. This represent many and this represent one. Meaning that a instructor can have many students. This one-to-many. Instructor can have many students, but a student can have only one instructor. That is what I have written wordings also. You can again in Fliss, if you take this left side, you can think as a team table, and you can right side you can take as a player. So a team can have many players using this one-to-many relationship like this. You can say. Is it clear?
Yes, sir. A player is related to only one team. Okay.
Mm. Mm. And many to one relationship. Again, I just represent everything using same table. And if you this because all I wanted is constant to represent this again indicates many without any arrow symbol. And using this arrow symbol, it represents one. So this is nothing but many to one relationship. So because why we are using this is in real time cases while designing the tables. So we might have an idea what are the tables I need to place. And you have to think about constraints. What type of constraints I have to give? This is one of those constraints. It is important in design if you carefully design a database. Okay. Here, the instructor can have only one student, and a student can have many instructors. It's nothing but many to one, one to one. It's just the opposite way. You can define it in any manner. It's just an opposite of one to one relationship. You can say in words, right? If we put like this, same table student here and instructor here, I just reversed it, right? This is many and this is one. What I did is I just reversed and drawn a diagram. This now again you can consider this as a one-to-many relationship. And in fact, this is used to happen. It's nothing but a vice versa of one to many and many to one. I hope this is also clear. Let's move to the next one. In many to many relationships. And how do we define many to many relationship is without any arrow marks. You can see now I don't have any arrow marks at each of the end. And many to many relationship, and each instructor can have many students, and student can also have many instructors. That is what it is given here, right? Looking at the table. And one more thing, what I wanted to say is for many to many relationships between two tables, if you wanted to have many to many relationship between two tables, and this intermediate relation, this is nothing but a relation, right? This is gonna act as a table in your schema. Because for many-to-many relationships, you need minimum of 3 tables. To represent many-to-many relationships in a schema, you need 3 tables. So in this case, this is gonna be your table in your schema, and this will also have some primary keys and some other attributes which will be linking together.
Also, this relation is a table.
In many-to-many relationship, you can consider this as a third table. Generally, it's called as relationship because in physical, not in terms of physically. If you wanted to define a many-to-many relationship in a schema on your database, you need 3 tables. So typically, you can consider this as a third table, not visually using the ER one, but there will be some intermediate table between instructor and student to join this, something like this, and it will have some ID, and it will have instructor ID, it will have student ID. All it will have is these primary keys to ensure both of the tables are being joined.
So some kind of Cartesian product between the two.
Not Cartesian product. It ensures both the tables are linked with a intermediate table so that it establishes a relationship. I don't know. I couldn't give any example from the database, whatever we have seen, this list or whatever. For example,
Hello, sir. Hello,
yeah, hello.
sir. Am I audible?
Yeah, you're audible.
As we see this suit, one instructor and a student, right? So many the features of many-to-many relation will contain ID and name both,
Hmm.
which are common to both this table, right? Or apart from this,
I'm not getting.
as you told, this will be a third table advisor, right? Which will be a relation.
You can think as a third table
Okay,
because
so
you
the
need a third
features.
table. Okay.
Can we say that the features of this table, which is a
Hmm.
relation, will be ID and name because ID and name is common in both of them.
The features of third table, you mean the
Yes, yes,
attributes.
yes.
So this is nothing but you will have some unique ID for this table, advisor ID, and you will have ID, instructor ID. You can say this instructor ID, which will be linking to this, and this student ID. Yeah,
Which
this will
are
be
common in
linking
both
to
the
this.
which are common in
Yeah,
both the
this. mm, Which is common in both, not you can say. Generally, we used to take a primary key that will act as a foreign key in this inter between table.
So we can say that the features will which will be useful to connect this to the
Yeah,
will be
primary key.
features of
Generally,
this.
it's primary key. So using both primary key, you can easily able to identify any of the term. It's not about
Okay.
the common attribute. It's primary key. Generally, we used to take.
Date also can be part of this thing, because the date of joining of this advisor can also be treated as an attribute, right?
Yeah, any other attribute, but these were something really important to uniquely identify. And additionally, you can have other attributes also.
Right.
So, sir, for one to many or many to one, to show the relationship, there must be a table also, like this one, many to many. We are saying that there should be a third table to show the
Mm.
relationship. So to
Only for many to many. not for one-to-one or one-to-many, many-to-one.
So how
Because
the
I have already given an example, the using a FLIS dataset, right? The manager and teams one is one-to-one, and teams and players have one-to-many. We don't have any intermediate table between them. It's already a one-to-many relationship.
one too many, but to show the relationship that which one is related to which, so which is, instructor is related to which students, which all, there must be a third table. How the relation will be established?
Using foreign key, right?
No, I am saying that for instructor A is related to 5 students. So how, where this is mentioned?
While designing the schema, while designing the create table, you need to ensure that that is one-to-many. It's gonna be. It's explicitly you cannot mention one-to-many. It's all depends on the constraints that we are gonna foreign key, right?
Oh, sir,
Foreign key is
for here
okay.
only, sir. Let's
Yeah,
take the,
I'll give you the example here. Okay. I'll take the FLIS one only.
no,
Uh,
I'm telling, not telling about one to
yeah, yeah,
one.
yeah, yeah. I'm getting the point. Okay. I'll come with one-to-one only first. Let's start with one-to-one. Let's say the teams table is there and manager table is there. Okay. Generally, how we used to create a schema using create table syntax, right? And the table name and whatever the attributes you have, team ID will be your primary key, right? Nothing else. And whatever blah blah blah. Sorry, name and team name. What is the jersey number? Anything. And the manager table, it's nothing but again you will create. While creating the manager table, you will have manager ID as a unique attribute. And something you have to define a foreign key also. And while creating the foreign key, team ID will be a foreign key. You can mention team ID as a foreign key. Okay. And this team ID references, okay, you will have to mention this team ID references team ID, right? And while defining this team ID as a foreign key, if you just say foreign key, okay, what it's gonna assume is, so a manager can be in one of the teams or many of the teams because you don't have a constraint. Even the manager cannot have a team also because you haven't mentioned not null constraint. Are you getting my point so far? If you
Yes,
are not mentioned not null constraint, a manager can be either he can be in team or he may not be in the team if he doesn't have not null constraint. And if you have a not null constraint, I'll clearly write it. If you have a not null constraint, if you have a not null constraint, a manager must exist in team stable, right?
Then it will become one-to-one relationship. Like
No,
each
no.
team.
Still, now what kind of relationship it will be there? If I say manager one, some name one, and if I put T001, and according to the constraint, again I create another manager name two.
Okay.
Again I put T31 because it does not violating my constraint. Well, whatever I defined to create a table, right? Because I just mentioned foreign key, not null.
Yeah.
Is it violating any constraint while
No, no,
inserting
no.
my row?
No, sir.
No, right? Again, what I will do, I'll add one more constraint, not null and unique.
Now
In
it's
foreign key, not null, unique. If I try to insert this one, again T001, it will definitely throw an error because I have a constraint called unique in the foreign key. my point?
Yeah, right, sir. Right.
So
Yes.
in this case, what will be the relationship? 1-to-1.
Yeah.
Because it's not directly you are enforcing the relationship. While defining the schema only, you have to enforce all those relationships. Okay. Now you might have got
So,
understanding how to define a schema and how to define relationship using the code. This is generally pictorially why I'm representing pictorial is this is how generally when someone starts to design a schema, this is how they generally use some software to design like this, or in olden days they used to design in paper also, because this is how the basic one. You cannot directly simply start coding in a SQL editor, because they should have a overall understanding. They first used to start designing ER diagrams, then only they used to code editor and start designing this.
so, sir, can't we define the many-to-many relationship in the same way that you are telling?
No, right? So see, this ensures 1-to-1, 1-to-many, or many-to-one, whatever, right? Because using two tables. If you take many-to-many, how do you ensure? Because here also there should be foreign key, something foreign key to say this instructor, sorry, this student has this instructor and this instructor has this student, right? And it will be very tedious if you put this. If it is 1-to-many, I'll have only one connection between like this. Okay, connection means this foreign key, okay, or like this. So it's easy to define it's 1-to-1, 1-to-many, or many-to-one. For many-to-many, what you want is you need a two-way of connection, and you have to represent like this, right? Because this is linked to this table, this is linked to this table, and which is practically not feasible to have this kind of relationship. That's why the intermediate table is coming to a picture, so that it or these two relationship won't link directly between those two. What it will do is it will link to this. So using this intermediate table, it will understand there is a many-to-many relationship between these two tables. That's something you have to remember.
Yes, sir.
And okay, maybe if you start typing SQL code using the same schema, then you'll be able to understand better. I can't say much. At least I hope 1-to-1, 1-to-many, many-to-one, it is clear, I guess. Because I couldn't give any real example using the schema, whatever we have seen in week 2 and week 3.
It is clear, sir.
Okay.
But sir, how can a relationship between become a table, sir?
How can you?
Relation becomes a table.
Relation doesn't become a table here. You need an intermediate table, of course. Because pictorially, if you design a schema, this is how you will be designing. And if you are having many-to-many relationship, of course, you need to have intermediate table with primary keys of both the tables to uniquely identify. That's why I said you can consider this relation as an intermediate table with all these attributes.
So what is the third table?
What is the?
How can you which attributes are there in the third table?
That you have to decide. Okay. In this case, if I have a third table, the necessary attributes are advisor ID, one that is the intermediate table which is gonna you have, and the ID from instructor and the ID from the student. These are all the necessary attributes which you need for your intermediate table. Then only you will be uniquely able to identify which student is having how many instructor, which instructor is having how many students. Additionally, you can have date of joining, the course started, the additional details, or whatever you want. But these are something necessary to have third table, intermediate table.
Okay.
Okay.
Okay, sir.
Let's move to the next one. And we have something called total participation and partial participation. And here, what does it mean is this double line indicates total participation. And the single line means it may or may not have. What does it says is every student must have an instructor. This double lines means must have. And the single line generally, it's again many to many relationship only. You can see there is no arrow marks. But instructor may or may not have a student. That is what it's implying.
So total participation means must have participation.
Yes. Every student must have at least one instructor. That is what it says, must have this double total participation.
This is also a kind of relationship only, sir.
It's many to many relationship, as I said. But you are adding one more logic. It should have total participation because according to the university, or this is what it comes like. Whenever you go and start designing something, they will use so many logics. It's not like that easy to design a database. If you want to design a database, you have to sit with the customer and you need to understand their business logics, and you might have to ask questions to them again and again. Then only you'll be able to come up with all these constraints, because every company has their own constraints. I don't know how many, if you are a working professional, you should be able to easily relate to this. And as I said, let's come to the weak entity set. How we represent the weak entity set. Here, this is a weak entity set. This is one of the very good example to represent a weak entity set, which is represented using double rectangle. And since this is a weak entity set, this is also a weak relationship, which we call as identifying relationship. As we have seen while discussing strong entities and weak entities, this is identifying relationship. So now, by looking at this section ID semester here, and for the course, this section ID 1 semester 2025, sorry, this itself you cannot say this is unique, because every time, let's take section ID 1 semester, again first semester, or I put S1 as section ID semester, first semester 2025. Again I will have section ID 2 or 1, again first semester, again 2025, again section 1 2025. This I can have right in this section, because I don't know all this section pointing to one course or different courses. If it is pointing to different courses, it makes a valid sense to have this, right? Because every course has some section, semester, years, and you will be having more than 50, 60, around 100 courses in a university. Does it make sense to have these kind of values in this section table?
Sir, how we are calling it weak?
This double rectangle.
No, on what basis?
Okay. By if I'm having values like this,
We
do you
can't
have
uniquely,
any?
we
Yeah,
can't uniquely identify.
you can't uniquely identify any of this, right? And this is identifying relationship. Since it has a weak relationship, we call it as this as identifying relationship. So in this case, what you need is
Sir,
something called.
can you repeat that part, sir? So how it is a weak relationship, weak entity? Why are we repeating the same rows?
Okay. Does it make sense to have these rows again and again? If I say this is course 1, this is course 2, this is course 3. Because all three courses can have in same section or first semester 2025.
Yes. Yes. A section can have many courses.
Yeah.
That's my repetition.
Hmm. And since all these values can be there in section table, and you are not able to uniquely identify any one of those rows, right?
So, sir, why someone will design such a table? What is the use of that?
That's up to the designing person. And because sometimes if you store all this one, uh, that again becomes messy or quite something. And also there is some part you might have to sacrifice performance issues as well that you might see in upcoming weeks. That's up to the person who is designing. If you are designing very well, you might have to sacrifice performance so that it doesn't have many redundant. All this will talk in week 5 and 6. So designing has own pros and cons. Some you have to sacrifice for designing a very good database schemas. And weak entity set. So since it's a weak entity set, you cannot identify anything. What you need to do is you need a primary key to uniquely identify this section. So that is course ID. So as we have seen, to uniquely identify any row in weak entity set, you need primary key of strong entity set. This is strong entity set. See, strong entity set plus discriminator, which is partial. So here you can take either all this as partial. Yeah, all these were partial key. Okay. Since I'll erase this. All this has been underlined, right?
Yes, sir.
This underline nothing but a partial. So all this is a partial key. So in order to uniquely identify any one of this, you need section ID plus semester plus year and
Course.
plus course ID. This is what weak entity set you use to identify uniquely, as we have seen in first one. So that was the doubt so many of you had. And the relationship which exists between weak entity set and strong entity set, we call it as identifying relationship. And again, it's representing as double diamond. Okay. And this is again a total participation. Because why it should be total participation? Because a weak entity set cannot exist independently, as I said, right? And
Yes, sir.
the as that's why it has total participation. Every section should have at least one course. Now I think all it's clear about weak entity set.
Sir, what is discriminator?
It discriminated nothing but partial. This the underlined one. It's
Okay.
another word of partial.
discriminator need to contain all the these features of weak entity, or maybe the subset of that.
Sorry.
This discriminator, does it contain all the these features of weak entity set, or it can also be the subset of those?
Subset of all those only. Here it's all, because since we need all three to combine with primary key of strong entity set, then only you will be able to uniquely identify. In
Section semester
so
and year
designing, it could
that
be
student.
subset also.
Okay, along with the course ID, we need section ID, semester and year to identify that student, right?
Yeah. Okay. Then move to the ternary relationship. This ternary relationship is something newly comes, right? And a three table will have a relationship together. That is why we what we call as ternary relationship. So far, we have discussed with respect to two tables only. So it has one to many, many to many, many to one, or one to many. So when it comes with the three tables, so we are calling that as a ternary relationship. And again, you need one more table, right, in order to link all this table, as we have seen in many to many. Because everything has to be linked with this intermediate table, something called project guide. And it should have primary key of this one, and primary key of this one. And any other additional attributes, project guide, who is the guide, when, from when onwards he is guide for that project. All these additional things you can store here. But these three were mandatory for the intermediate table. Is this clear? Okay. Then comes to a topic called aggregation, where we consider a bunch of tables and relationship together as a single relationship. So that is what we call as aggregation. Here it's same thing.
Sir, so here
teacher.
we are consolidating all the relationships so that we could make a new relationships between others, right?
Here teacher, student, project. All these were tables, and all this has been linked to project guide, and project guide also has one more attribute, since along with the primary key of teacher, primary key of student, and primary key of project. And this is itself, you can see, as we have seen, this is a ternary relationship, since it has three tables and connecting with intermediate table, and this is the intermediate entities. Sorry, entities, not entities, attributes, right? And we are considering this ternary relationship as a single entity, and we are defining the relationship with the examiner table here, or examiner entity set. And this is again have unique keys, and the evaluate is denotes a relationship, and this again having a date of evaluation. So in this case, what are the attributes that you need to have in each of the table? That is also given here, right? So these three were as it is, since it is a entity sets, and the examiner is also given as given seen here. This is also entity set. But this project guide and evaluate or relationship, that is what I was telling, like you need to have an intermediate table. So if we are having an intermediate table, what are the mandatory attributes that you need to have in order to
Primary keys of both
have
the
that
tables.
relationship? So it has all those primary keys wherever it is linked, as you've seen, teacher number, project number, student name, and the attributes which is additionally needed for that type. So we can store any other information, not only since the end date of project, also you can store it. And similarly, evaluate. This is a relationship again, but it's holding a relationship between a ternary relationship and between one more entity set. And again, you need to have primary keys of all those entity set, teacher, student number, project number, examiner number, and the date of evaluation, which is all extra attribute from your evaluation table. And you can have other things also. This is a little more complicated, I know.
Sir. Hello.
Okay. And let's move to the next one.
Sir, I have a question.
Okay.
Like in this two tables, we can write this or form the tables, right? And give the foreign key. In case of this three table, how to handle that? If you
In
want to
case of
three tables, ternary relations. So we need
your
to handle them with the foreign key and primary key and all those.
yeah, right. Here you will have instructor ID, student ID, and the project ID, and the date of project or any other attributes. And you can have a primary key for this table also, project guide ID, something. Because all these primary keys will be acting as a foreign key to this intermediate table. So that establishes a relationship between all three. Okay, any doubts? Is it clear?
This one is also a ternary relationship, na? The which one you are showing above the aggregation.
Yeah, this is ternary one.
Okay.
This ternary one only we combine with aggregation, same one with attributes denoted like this. You can get similar kind of questions in exam because entity set will be represented like this and attributes will be represented like this circle with underline dashes, all this things. And coming to the next one, the concept of overlapping and partial. This is again the entity sets, you can say. A person can be either student or faculty or both. It is what it says, overlapping and partial. And also there could be some persons who are just in persons, but they do not belong to faculty or students. Basically, you can consider this as a role-based one. If I am a student, I cannot be a faculty, but there could be some persons, all user of your website, he's also an admin, kind of that, you can say. Because there is consider there is a admin manager user. Uh, so there could be some users who is also a manager and admin. There could be some users who are just managers and user. There are generally all those were users. That is what it's trying to say, right? A person can be this one, especially look at this symbol, this one, this arrow, not this one, just this one. It should be triangular. So this says a person can be either student or faculty. It doesn't mandates. Okay. That is we call as overlapping and partial. And,
Sir, it is called
next
ISA,
one,
right? ISA
Called?
is something professor has used some terminology of SQL language, ISA, to demonstrate overlapping.
I'm not sure. They might have to revise, I guess. I'm not sure.
Okay, sir, no problem. Let's move forward.
Okay. So this is how you represent the partial relationship between them. Since it doesn't have any common between, it's just overlapping. Yeah, okay. And coming to the next one, disjoint and partial. So since it has both a student can be just students, or they can be undergraduate student or postgraduate student, right? That is what it's saying. He can be either UG student or PG student, but he cannot be both UG and PG students. And also there could be some students who are just students, UG or PG. They may not lie in this category, but they are students of PhD, MS scholars. But here in this case, a person could be a faculty also, a person could be student also. This is difference between this and this one. Carefully look at those diagrams. Since this is also this triangle arrow, so that is denotes a partial. And here, this symbol, something called like this, it will be denoted here total. And every this is complete, disjoint and complete. Every part must be present in either purchased part or manufactured part. At the same time, a part cannot be in both purchased part and manufactured part. It doesn't make sense also. So it should be either purchased part or manufactured part. And definitely it should be. That is why it's called total. So this
Sir,
is a
sir, could you
disjoint
once
and
again repeat joint and disjoint once again? So the previous slide and this slide.
the difference between disjoint and complete and disjoint and partial is this one. Just this one only. If it has, this is complete. If it doesn't have, this is partial.
So a student can contain those student also who does not belongs to PG and UG, but in the case of disjoint and complete, it should the part should only have two parts, only purchased and manufactured. Is it the case?
Yes. Yes, yes. Okay. Anything here?
No, sir.
Okay. Finally, and I think that's all. And this is the summary of what we have seen today, right? And this rectangle represents entity set. This diamond represents relationship set. This double diamond, as I said, this is identifying relationship set for a weak entity one. And this double says total participation, double line. And if they have given in form of table, this is a attribute, simple one. And this is a composite one. This is a multi-valued attribute. And this function parenthesis like this. This is a derived attribute. And if it is underlined, it's a primary key. And if it is dashed like this, it is a discriminating attribute of weak entity set. You can say as discriminator. And you have to remember this one. This means one. This means one to one. This means one to many. And this means many to one. and this means many to many.
Many.
In order to have many to many relationship, you need one more intermediate table. Same goes for more than two tables, ternary or aggregation. You need an intermediate table, and that intermediate table should have a primary key of both linking table, and that will be acting as a foreign key in the intermediate. Is this clear so far? Whatever we have seen.
Yes.
Yes, sir. Sir, a few terminologies like there is a terminology called roles in ER diagram.
Roles.
Yes, sir. Uh,
In a relationship one you are saying, right? Roles are not different.
like like in an ER diagram between like it was written on the lines actually.
Course and prerequisite. The example is given. Course and prerequisite.
Yeah, exactly, sir. Yeah.
Yeah, in the lecture, video lecture.
Yeah, in the lecture it was given. It was not that clear actually. If possible, could you
Yeah.
say what it is
No,
actually?
not in this, in the lecture video.
Okay.
Sir, another thing, what is the meaning of redundant actually? Like to the core, I want to understand it.
Redundant means it's unnecessary data that you are storing in your database.
Does it mean repeating?
Not like repeating. If I okay, the best example is the timestamp one I can give you. If I'm storing a timestamp of whatever the work the employee or the person is doing a activity in my application, I can store a timestamp so that why I'm storing this timestamp means okay, at this timestamp this person has done this work, or this person has done some changes, or this person has ordered something, right? So using the timestamp, I'm noting down, okay, this person has ordered these many things in this timestamp. If you wanted to know on which day he ordered, on which year he ordered, on which month, on which hour, is it good idea to store all this information in a table?
No, sir.
Because you already have a timestamp which contains all those information, because timestamp is nothing but a date and plus the time, which includes hour, minutes, seconds, right? So using this, you can definitely will be able to extract all these questions what you asked. So since you have all this information within this, you don't need to store separately as another attribute. This contains a redundant information, and it's gonna occupy, of course, more spaces. It,
Understood, sir. Uh, could you give a clarity on roles, sir? That roles part.
sure. Okay, I'll
Sir,
stop
could you
sharing.
please share this PDF in the chat?
Haven't uploaded in Drive or anywhere. As of now, it's in my local system. Okay, just wait a minute.